Good morning and good afternoon. My name is Peter Matthews. I'm the editor of Firehouse.com, and I'd like to thank everybody for joining us on today's webcast, Understanding Smoke Particle Risk and Exposure. Today's speakers include three experts from the industry who have a passion for firefighter safety and health and are working to educate firefighters to find solutions for smoke particle risk and exposure. We'll be hearing from Bob Keys, Kevin Roach, and Jan Sean. Thank you to DuPont for sponsoring today's webcast that tackles a topic that's near and dear to all of us in the fire service with all the research findings that are coming out. We really appreciate your support. For those of you who have joined us on previous Firehouse webcasts, today's format will be a little bit different than our traditional webcast format. The speakers will present the entire presentation before we get to the questions, but please send your questions in. We would love to have an opportunity for Bob, Kevin, and Jan to answer those as we wrap up today. And without any further delay, it's my great pleasure to introduce Bob Keys, Kevin Roach, and Jan Sean.
Thank you, Pete. Good morning, good afternoon, everyone. We have about an hour presentation, and we hope that you will, as Pete said, submit your questions as we go through the presentation. We're going to be speaking today about understanding smoke particle risk and exposure. And again, we have about an hour presentation total. We'll start out by doing our introductions. My name is Kevin Roach. I retired from the Phoenix Fire Department about 3 years ago. I was with the department for almost 25 years. I spent most of my time in Phoenix in logistics, a little bit of time in fire prevention, and then finished out my career in Phoenix as the Chief of Staff for Chief Kahn and for Chief Kalkbrenner. And it's a real pleasure to be here today, and it's a pleasure to introduce Bob Keys.
Well, good day. Hello, everyone. My name is Bob Keys. I just recently retired from the New York City Fire Department after a 31-year career. Started way back in the dark ages in the early 80s in the Bronx. I worked in Midtown Manhattan, worked in Queens for a while, back to Manhattan where I loved the excitement of Midtown. I was there as a captain, and then promoted to battalion chief in '99, where I was assigned to the 3-9 Battalion in East New York, Brooklyn, in the 15th Division, one of the busiest parts of New York City. Perhaps my most rewarding assignment in my entire career happened in the last couple of years. I was on the job. I was asked to take over as the chief in charge of research and development, and I learned a tremendous amount about how innovations happen and how firefighters can become better protected through partnering with manufacturers and sharing best practices with other firefighters around the country and challenging the industry to come up with innovative ways to better protect firefighters. So it's with great pleasure that I am glad to share those experiences and the continuing education I have in hopes that we can do something to make a difference and make firefighting a little bit safer. So thank you very much for signing in today. Now I'd like to introduce our third participant, Jan Sean.
Good afternoon, good morning. I'm Jan Sean, Global Technical Leader for Emergency Response in DuPont Protection Solutions. I have 20+ years of experience in technology research and product development for medical device and the personal care industry. I am very grateful for the opportunity to work with Kevin and Bob, as well as a DuPont team, to bring new technologies to improve safety and well-being for our firefighters. I also want to thank our audience today to spend your quality time with us. So thank you very much. So our agenda today will be covers why the modern day fire so dangerous or so deadly. And we're also going to be looking into the gaps between modern days fires as well as existing PPE protections. We're going to look into the gap and how the industries collectively come to a solution to resolve the gaps. And we're also going to be talking about the game-changing technology. Finally, we're going to touch upon how we can systematically and better protect our firefighters.
Thank you, Jan. We're going to start out by talking a little bit about a brief history of firefighter turnout gear evolution. Back in the olden days when Bob was a new firefighter, that's actually him at the far left photo there. He's actually the firefighter standing on the right. From about 1900 to 1960, firefighter turnout gear was mainly about water resistance and keeping the firefighter warm. There was very little thermal protection provided by that gear. It was generally made of natural fibers like cotton and wool, and in some cases the coats were coated with rubber. At the time, again, limited thermal protection, and the price of turnout gear at the time was about $25 a set, which seems quite small compared to the price of turnout gear today. In the mid-60s, about 1965, DuPont developed two new fibers for the fire service, or for application in the fire service, Nomex and Kevlar, and these were the first inherently flame-resistant fibers to come to turnout gear. In the past, again, it had been mostly natural fibers, but these are actual fibers that will not melt or drip when exposed to heat, and the price of turnout gear for a coat and pants at the time was about $100. As we get into the 1990s, and the picture to the right of the 1990 logo there is a picture of a European firefighter, probably Ireland or England. The concern about bloodborne pathogens was brought into turnout gear, and the turnout gear not only provided thermal protection for firefighters and water protection, but also provided protection against bloodborne pathogens. As we get into the 2000s, concerns about other chemical hazards came to the fore, and the CBRN option was added to turnout gear. The materials that were making the outer shells of turnout gear and the inner layers became higher strength, and there was a movement to try and assure firefighter comfort in the turnout gear and avoid stored energy. The turnout gear would not harbor energy that would later burn the firefighter, that it could release that energy more quickly. And the price of turnout gear around now is about $2,100 a set or more. As we look into the future, after 2020, companies are beginning to integrate smart technology into turnout gear, looking at it's possible now to measure the firefighter's heart rate, blood pressure, temperature while they're wearing turnout gear. And of course, firefighters wear their gear for multiple threats, not just for structural fires, but for non-structural fires, EMS calls, vehicle extrications, and so on. The focus of a lot of industry effort now is to reduce the thermal stress and physical stress that turnout gear puts on firefighters. As anyone who's ever worn turnout gear knows, the microenvironment that's created by the turnout gear can be very stressful for firefighter health and safety. This next slide just takes a look at the NFPA report on on-duty firefighter fatalities. This would include career and volunteer firefighters, but it does not include the horrible toll, all kidding aside, from 9/11 in New York City, the 343 firefighters that died in New York City on 9/11. But the trend is generally down, which is very hopeful. These are the type of deaths that would be included in this graphic would be firefighters that were caught or trapped in buildings, firefighters that were burned or drowned or ran out of air inside a building, the normal line of duty deaths that you'd think about. So the trend is hopeful and downward trending, and we think also that the better protective clothing is a part of that downward trend. If you look on the left-hand side of this slide, one statistic that's not captured in the previous slide is the number of firefighter cancer deaths. Firefighter occupational cancer is front of mind in the fire service today, and it's really been described accurately, I think, as an epidemic. If you look back in time on the graphic on the left, in the 1950s, these are firefighter fatalities that are memorialized in the IAFF Memorial in Colorado Springs, Colorado. If you look at the 1950s, less than 1% of the firefighters that are honored on the memorial were cancer deaths. And that number just continues to grow to the point at the second to last line of that graphic, the last line of that graphic, from 2010 to 2016, 2/3 of the firefighter fatalities that are memorialized in Colorado Springs are as a result of cancer. If you look at the graphic on the right there, you can see that there were very few. The orange line is the cancer deaths of firefighters. You can see there were very few back in the 80s and the 70s, but that number has steadily grown and contributes now about 2/3 of the firefighter fatalities that are on the memorial.
So what are the contributing factors that are leading to this cancer epidemic in firefighters? Through many seminars and shared best practices and education that I've received from being so involved in this mission to help make firefighters safer. What we've learned is that there's a tremendous difference in modern day building construction that we didn't see back in those dark ages and when I started ancient history. And by the way, that was not really me in the picture. That was Kevin. He was just saying that about me. Modern day buildings are now made of so many artificial man-made materials. Traditional or legacy buildings were made of wood and bricks, cement, and steel. But nowadays, we're seeing so many plastics and adhesives that are used to make not only the exterior construction of buildings, as you see in that picture on the left, but as well as the interior furnishings, tables, chairs, things that used to be made of wood are not being made out of wood at all anymore. So, in fact, one firefighter referred to modern day construction material as solid oil. They really are just these petroleum products that have been modified to become solid material that makes up a lot of the furnishings, not just the rugs and the wall coverings, but lots of the furnishings and construction material is giving off these toxic substances that are released into the air that we as firefighters are exposed to in so many different ways when we just show up to do our job. One of the contributing factors that has been identified, and we've made some good strides forward but need to do a lot more, is our improper protection. We've for many years been taught, well, back I was taught when I first started fighting fires, to conserve the air I had in my SCBA because if the fire got worse, I would need it to get out. And so we were using our lungs to filter the smoke, really. It was a terrible improper practice, but little did we know. The education was just not out there back in those days. No one thought that we would ever get cancer. That was for sick people or for smokers, not for our healthy firefighters. So luckily the word is out there, and now firefighters more and more are wearing their SCBA throughout the entire overhaul procedures that we do in fires until we leave the IDLH, that dangerous environment filled with smoke. So we had some improper protection. We did not wear the best materials that could protect us from these toxins, but through partnering with manufacturers and through lots of in-depth studies that we're going to talk about today, we're doing a much better job of protecting ourselves. And the other big avenue that we've made a big change positively for is making sure that we do not bring our dirty PPE back into the living quarters and firehouses or back to our homes. Those garments need to be deconned as quickly as possible, and we should not allow humans to be in the area where they're off-gassing. If they smell, you should not be anywhere around them. So we need to do a better job. We're doing a good job, but we can do better by making sure that we don't idolize firefighters that are walking around with that salty, dirty bunker coat, trying to use it as a medal or a badge of honor. It really is not the smart way to fight fires. As another friend of mine recently just said, clean is the new salt. We don't need to be salty. We need to be clean to be smart, to survive. This next graphic I'd like to share with you is a little bit confusing. There's really a lot of information on it, but I'd like you to just focus on the blue and the red line that are in here. The red line is the legacy buildings, the older buildings we were talking about. The blue line is modern day construction type buildings. Now these scientific tests done by Dan Majorkowski, doing this fantastic work at Underwriting Laboratory, they took under control environments, compared different furnishings and building construction materials, and amazingly how fast that blue line climbs within the first 5 minutes of a typical fire that we would see responding to a home or apartment. The furnishings just decompose so fast, and they generate so much more toxic smoke particles that are in the air. So firefighters arriving on the scene are exposed to so much more heat, quicker buildup. It rapidly declines because it consumes all the oxygen. But then as we show up and ventilate to gain entry into the building, it takes off again and flash over and releases so many more of these toxins through a chemical chain reaction. And this is the hostile environment that we as firefighters find ourselves in.
So what is the smoke and why it's so toxic? If we were to take a bottle of a smoke sample from a fire ground and take a very close look, smoke is really a mixture of everything. There are particles, aerosols, and gases. They are extremely small and tiny when we look under a microscope. One of the UL reports suggests that 99% of the particles are smaller than 1 micron. The examples showing here are wood and oil soot. but both display tremendous voids and pockets where chemicals love to gravitate to. They are very tacky and love to stick on everything they've touched. So smoke is really a carrier for toxic substances. They kill hundreds and thousands of people every year. A study done by Harvard and Columbia University estimated that in 2015, more than 100,000 people in parts of Southeast Asia died prematurely from breathing the noxious smoke-related fires that were set to clear land for agriculture. The biggest health threats from smoke is, again, those microscopic particles. They can penetrate deeply into our lungs. They can cause a range of health problems, from burning eyes, running nose, to aggravated chronic heart, lung disease, and even cancers. When those flammable, easy-to-melt materials are combusted, two forms of chemicals are mainly developed. One is what we call volatile gases, which are usually released at the room temperatures in hours and days. Some that we can smell and some we can't. Typically, these chemicals are usually gone after 3 to 6 hours of a normal fire activity. The semi-volatile compounds are those that are released at a higher vapor pressure or higher temperature. They love to adhere on the surface of smoke particles and soot. Once again, those gooey stuff are very sticky and tend to get into our hair, fingernails, gear in days and months to come if we don't wash them away. So we should never carry dirty gears to our personal cars and houses. The International Agency for Research on Cancer, IARC, classifies chemicals in the Group 1 as carcinogenic to humans and Group 2A as probably carcinogenic to humans. With that, IARC has identified a number of chemicals that are in the Group 1 category, such as soot, formaldehyde, benzene, and diesel engine exhaust. Some can be found in the fireground, station, and gear. Some may be more prevalent in the fireground.
Okay, so we realize now that there are some really, really bad toxins inside most fires that we're fighting across the country and everywhere in the world these days. The next section is going to address gaps between modern-day fires and existing PPE protection. So, how do these toxins enter a firefighter's body? Well, 3 major ways that they can. The fastest and easiest is through inhalation. But as we talked about before, if we have good SCBA policies and practices in our department, and we stay on air until we've left the IDLH, left that toxic cloud of smoke that exists inside the building, stay on air all the way through overhaul, we can easily block the inhalation portion of that. And that includes deconning, keeping that SCBA on all the way through decon. The other avenue that we're finding out through lots of studies that are being done throughout the Illinois Fire Safety Institute, UL, many different organizations that are involved in evaluating how our firefighters are getting contaminated, shows that the skin area is a slow absorption, slow ability for toxins to get into the body, but because our skin is such as the largest organ on our body, there's so much surface area, it does not require a lot of area for high levels of toxins to enter your body and then get absorbed, distributed, and metabolized throughout your body. Ingestion is another topic that was just brought up at the most recent conference I was at. Of course, we would never eat something while we're fighting a fire, but do we do a good enough job of deconning before we head to our rest and recovery areas, to our centers where we get a bite to eat, a cup of coffee? One identifier that just came out is, sure, we take one contaminated glove off with another good glove, but how do we get the first glove off then? Usually with our bare hand. How many of us really understand that now our hand has contaminants on it, and we really need to do a good job of using wipes, using soap and water to get it off as quickly as possible. So another great independent study that was done that I want to share with everybody here was done by the University of Kentucky. They wanted to find out, is all skin equally porous? And what they found out is no, absolutely not. As a matter of fact, the most resistant skin, the thickest skin on our bodies is on our forearm. They used that as a reference point then and looked at where is the most porous part of your body. Well, for guys, it's in your groin area. For everybody, the second most is your armpit. And then the third, fourth, fifth, and sixth most porous skin on our body is at the top there, the jaw, behind the ear canal, the forehead. That's the area where our skin is the weakest to resist these toxins that are sticking, as Jan said, these sticky toxins that like to adhere to our skin. Well, they found out also in high humidity areas, it sticks even better and it increases our absorption rate. Then another excellent test that was just brought out and given as best practices in a white paper done by the Firefighter Cancer Support Network a couple of years ago. It showed that as skin temperature rises merely 5 degrees, the skin becomes up to 400% more porous. So we're talking here the third, fourth, fifth, and sixth most porous skin in our body. Humidity makes it more porous, and then as the temperature rises, which happens in every fire fight, we could be becoming even 400% more absorptive. So I think from listening to all these experts, these independent analysts that are trying to help fight this cancer epidemic, we've identified a possible avenue where firefighters are getting contaminated. Well, this next test that came out really visually proved that we've found this potential area that we need to identify and better protect. This test was commissioned by the International Association of Firefighters a couple of years back. It's called the FAST test, or Fluorescent Aerosol Screening Test. It's used by the United States military to identify how effective their chemical warfare outfits that soldiers would wear when they're anticipating potential use of deadly toxic warfare, weapons of warfare. And we decided that this group decided that why don't we use this test to evaluate how these tiny toxic particles in a typical fire could be attacking firefighters. And the results were glaring, unbelievable. So inside this chamber, the Research Triangle Institute suspends tiny, tiny particles of harmless silica that have a fluorescent marker on them so that they will show up under ultraviolet light or a black light. So these particles are the same size of those toxins that Jan identified that exist in everyday fires that we're at throughout the world. They're 0.1 to 10 microns, really, really invisible tiny particles. Well, these imitation silica particles were suspended in this room with a 10-mile-an-hour wind for 30 minutes, a firefighter dressed in typical PPE. We're talking bunker coat and boots, pants, gloves, 2-layer knit hood, an SCBA on, breathing on air, helmet on with the ear flaps down, collar up with the throat tab closed. And this firefighter went through typical operations that we would anticipate firefighters do every day. Crawling, walking, simulated overhead pulling, activities that create a billowing effect of the air pockets that are inside the turnout gear that create air to move inside and outside by typical everyday activities. After 30 minutes, this firefighter came out of the chamber and they carefully removed his bunker gear and his SCBA, and comparing the pictures they took of him before he entered the chamber to the pictures after he came out of the chamber, you can see in the bottom right, his calves did get some of these particles attached to him, but note he was wearing shorts while he was doing this operation. You can see in the middle picture on the right, his hands and his belly did get some contamination. But the glaring picture that resonates with all firefighters everywhere is the one at the top right that shows how many of these particles penetrated his PPE and adhered to his, remember, very porous, most absorptive skin in his body was covered with these artificial, but in real world, this is where the toxins possibly are entering our firefighters' bodies. That neck, that ear canal, the jawline right there shows that that's where a tremendous amount of exposure has been identified. So that test has really led a challenge to the industry to come up with a better solution. We need to protect that neck, that interface and neck protection. It's glaringly needed. So the next slide is just a comparison about how much money we're really spending to protect our firefighters. You see the total list of the bunker gear. A well-funded fire department is putting $11,000 to $12,000 into each firefighter we send into battle. But amazingly, the area that we've just identified as the weak link in our protective ensemble is getting less than 1% of that amount of money to protect it. Those two-layer knit hoods have always been thought upon as just a disposable item, but what tests are showing now is that we've got to do a better job to protect that area. So it's paramount that we do that for our firefighters, because certainly we've identified a possible avenue for these toxins to enter our body. So I'm going to pass this on. The next section about bridging gaps through collective initiatives is going to be Kevin.
Thank you, Bob. We've talked already about why modern fires are different and the gaps between modern-day fires and existing PPE. I thought the IAFF fast test is very, very important to see. Now we're going to talk about initiatives that the industry and firefighters have taken and fire service organizations have taken to try and bridge this gap. First, I'd like to talk about is NFPA Initiatives. NFPA 1971 is the standard for turnout gear, basically, for structural fires and for high radiant heat fires such as aircraft fire rescue and industrial fires. So that committee is made up of fire service and industry folks and scientists that set the standards, minimum standards for firefighter protective clothing. The committee assigned a special task group in October of 2014 to look at barrier hoods for the fire service and to set standards for the fire service. Some of their other initiatives were to initiate a project on how clean is clean. We want to make sure that when we're laundering turnout gear after it's been used in a fire, that cleaning is effective and that it gets the most amount of toxins as possible out of the turnout gear when it's washed, and that project's still in the works. Bob mentioned the IAFF fast test that he showed just a minute ago. That was performed in 2015. And the committee really challenged manufacturers to develop particle barrier hoods. At the time, there was no requirements in the standard for barrier hoods, but they really challenged the industry to have a look. As the industry worked, the committee also did work. They finalized requirements and key testing methods to evaluate particle barrier hoods against the standard. And the committee is currently working on additional developments in NFPA 1851. That's the standard for the selection, care, and maintenance of all turnout gear, including particulate hoods, so that barrier hood. So that standard is still in the works. In the 2018 edition of NFPA 1971, that's the edition that's just now coming out. The edition was approved it went through the whole NFPA process, including public comment. It was approved as an American national standard in August of 2017, and it adds a new definition and minimum performance and testing requirements for particulate barrier hoods. I want to point out, though, that there's no requirement that hoods have a particulate barrier capability. Hoods without particulate barriers can still be certified to the NFPA 1971 2018 standard. So it's an optional part of the protective clothing, not required. The standard specifies minimum areas that should be covered if a barrier hood is used. For example, the area around the neck and the ears that Bob showed in the fast slides is required to be covered, but areas such as on the top of the head where your helmet would normally be riding is not required to be covered with a barrier material. All barrier hoods should be certified to the 1971-2018 standard, and UL has actually begun that certification process for a number of hoods. The standard requires, as it does with turnout gear, the regular turnout gear, the coat and pants, that the hood has to be labeled as providing limited particulate protection, just as the turnout gear provides limited thermal protection for firefighters from fires. If you look at the requirements for particulate barrier hoods that are in the standard, there's really no change from the 2013 edition for the base hood. The first 5 lines there, thermal resistance is the same, it cannot melt or drip. Flame resistance is the same, very little char and very little after flame. Very little thermal shrinkage if the hood is exposed to heat. The TPP, the thermal protection that the hood provides, the minimum is still 20 calories per square centimeter, as it was in the 2013 edition. And the burst strength for the hood is at 51 pounds, according to a test that's in the standard. What's new in the 2018 standard is the particle blocking efficiency. Again, this is for the small particles that Jan described in her part of the presentation, from 0.1 to 1 nanometer, the hood has to be able to block 90% of that size of particle in a test that's specified in the standard. And then also of note is the THL. THL is total heat loss. It's a measure of the comfort of a hood, and there was no requirement in the 2013 standard, but in the 2018 standard, there is a requirement that the hood have a THL of at least 325. So again, THL is a measure of the comfort of a hood. The higher the THL number, the more comfortable the hood is to wear.
Okay, so what are the firefighter initiatives that have been going on that we've been lucky enough to be a part of and learn from and share best practices from? Well, lots of departments are holding symposiums and cancer prevention organizations. One that comes to mind in the forefront right away is the Boston Fire Department, which it seems is leading the charge in identifying the challenges. Every 2.5 weeks, a firefighter in Boston is being diagnosed with cancer, and that's just unbelievably devastating and challenging. But the Boston Fire Department has met the challenge with educational videos and change in culture and really educating every one of their firefighters, and doing that also educating the whole area, the whole country, and getting out there and speaking about what needs to change. Kevin and I were very fortunate enough to, I was fortunate to attend something that Kevin organized in Phoenix just last month. The Fire Service Occupational Cancer Alliance was really bringing together every major organization in the country in a consortium to try to identify what we're doing wrong. It was really an alphabet soup. Every different organization was represented there. It's had some excellent speakers that have been doing cutting-edge research about identifying the challenges, finding out what we can do about them, and ongoing studies that require real cooperation throughout all firefighters everywhere. The IAFF has done an excellent job in leading this, also putting together these venues and educational seminars and funding different testing. And we've seen lots of departments willing to do wear trials and then share their feedback, which is really, it's the end user that matters most. Every firefighter that's on this call knows what happens in a lab is not the same as what happens fighting a fire. And so it's these end user wear trials, these firefighters going into fires day in and day out that are going to be the real judge of what the best way to block these particles, but keeping situational awareness. I mean, it would do no good for us to put a bunker coat over our head to protect us from the particles, but you'd lose your situational awareness. You'd be totally encapsulated. You wouldn't be able to hear. You wouldn't be able to feel the rapid buildup of heat. So the compromise there is what the industry is working on right now. We've come up with some really good solutions that are being tested and being worn by firefighters everywhere. These hoods, of course, have to be inherently flame resistant. They have to block those particles at a high percentage rate. They have to be breathable. Firefighters are overheating at a rapid rate to start with. We just really need to see some hope of getting some of that moisture out of off of our skin to enable us to cool down, but also to be able to hear. I mean, if you put a plastic bag over your head, you really are limiting your ability to hear. And we also don't want the barrier to make noise itself. There are some materials that, when they're right over your ear, can really become disturbing if they're noisy. So that, again, focuses on situational awareness. And, of course, it goes to mention, of course, these things have to be durable. They have to be able to handle multiple washings, and they have to be able to live up to the harsh environment that firefighters are involved in every day. So we've seen some real progress forward on the manufacturer side. In 2016, at the Fire Department Instructors Conference in Indianapolis, Indiana, held every year in April, it's really the opportunity for all manufacturers in the industry to bring out their best and newest innovations, to launch products that the manufacturers have a lot of confidence in will make a difference in firefighter safety. So we were able to see at that conference 2 manufacturers that came out with barrier hoods that were using Nomex NanoFlex technology from DuPont, and one that was also using a membrane base. Well, in just 1 year, the 2017 conference just this past April doubled that number of manufacturers that are out there. So the industry is taking notice. Firefighters are asking for these products. We're wear trialing them. We're seeing what kind of a blocking technology is going to work best to keep us safer, and what's going to be durable, and what's going to be the game changer for firefighters' cancer challenges.
Thank you, Bob. Just want to mention that the Fire Service Occupational Cancer Alliance conference that was in Phoenix, Bob gives me too much credit. I was just a little tiny cog in the wheel at that conference. So on this next slide, North Carolina State University has done a couple or is involved in a couple of Department of Homeland Security sponsored projects to look at where there's leakage in the turnout gear, where we may be exposed to particulates in other parts of our turnout gear. So they looked at a number of different ensembles and found that there is leakage, not just in the head neck area, but as the FAST test showed, there is leakage also at the waist, wrists, and ankles. So industry is starting to address all of those. The second project is going to be to develop performance criteria for turnout gear in these interface areas as time goes by. So there's a lot of research being done. In my short time in the fire service, the issue of fire service or firefighter occupational cancer has been one that has really gotten the attention of the fire service faster than any other issue that I've seen during my short career. And everybody is jumping in. There are research institutions that are jumping in, testing laboratories like Underwriters Laboratories, Fire Service Institute, the Illinois Fire Service Institute, Dr. Gavin Horn and his folks, Dr. Denise Smith, are working very hard. This is all in addition to the sort of the grounding efforts that were done by the IAFF and the Firefighter Cancer Alliance. So it's very heartening to see the number of organizations that are involved in the issue of firefighter cancer. So as we go through our agenda, Jan's now going to talk about a game-changing technology that's been developed by DuPont to address firefighter exposure to particulates in the hood and turnout gear area.
Thanks, Kevin. DuPont has a long and outstanding history in developing and manufacturing protective material for fire service community. For example, Kevlar and Nomex are the most trusted brand names used as a PPE in the fire service globally. We know to do a good job, we have to find a right tool. So to capture those submicron or nano smoke particles, we need to have a filter that has a submicron structure. And DuPont's Nomex Nano Flex is such a material that can solve this problem. With years of research and development work, this is the first time in fire service history that an inherently flame-resistant submicron material has now been developed and it's being used by our firefighters. So what is Nomex Nano Flex? The Nano Flex is a nonwoven made of continuous fibers at the submicron to nanoscale. When we compare to a human hair, the Nomex Nano Flex fiber is 100 times smaller. Typically, they are in the range of 0.5 to 1 microns. And if we compare a piece of Xerox paper, the Nano Flex is about the same thickness. It weighs only 1/3 of paper weight. Nomex Nano Flex is a cotton candy ball in a flat sheet form. When we squeeze hard enough, it claps into the size of a small peanut. So what's left is the fibers, and what's gone is 90% of air. Air is our best friend. It not only provides us with great thermal insulation, it also brings the breathability, comfort, and ergonomics. And more importantly, the small fibers provide us with an excellent foundation for particle filtration. So in summary, Nomex Nano Flex is thin as a paper and light as feather. To develop a barrier hood that the firefighters want to wear, as Bob mentioned earlier, we need to have a thermal resistance, durability, filtration blocking, efficiency, as well as comfort and good situational awareness. A typical Nomex Nano Flex hood is straightforward by adding nano as a barrier material in the middle of the incumbent hood to make structures of 3 layers versus current 2 layers. The scanning electronic microscope images on the top right is a hood with Nano Flex being enlarged by 35 times. As you can see, the top and the bottom layers are the typical knits And the middle layer is the submicron Nomex nano fibers. The particle blocking utility is really coming from the NanoFlex, while the strength and the mechanical durabilities are protected by the nets. For a traditional hood, the particle efficiency, which is represented by the black bars, is only around 20 to 30% when tested at a particle size from 0.1 to 0.8 microns. However, by adding a layer of a Nomex NanoFlex in the hood, could improve the efficiency by 4 times or 99%. As nano is so light and thin, it adds only 10 grams of weight, pinch of salt, which accounts for 6% additional weight and a 4% additional thickness. Now, this additional layer, however, adds 25% more of thermal protection performances, TPP, for the entire hood. One of our hood manufacturers recently washed 6 hoods for 100 times and another 6 hoods for 150 times. We then did a blocking efficiency test on all 12 hoods and found all hoods maintained outstanding performance as those never have been washed. Their performances are shown by the red bars on the right of this bar chart. It's really amazing performances. We also did a fast test both in a qualitative and a quantitative methodology mannequin developed by Research Triangle Institute. The reason we use mannequins for the fast test are twofold. One is that we wanted to focus our study only on head, neck, and shoulder areas. And the second, we wanted to have a repeatable and representative data to avoid any background noises and the potential cross-contaminations from other areas or by different movements from live participants. In the qualitative study, mannequin 1 and 3 were wearing hoods without NanoFlex, while 2 and 4 were covered by NanoFlex hoods. As you can see, the nano hoods completely block the fluorescent particle penetration. On the contrary, we can clearly see fluorescent particle left on the entire shoulder and the neck area on mannequin 1 and 3. In addition, we also did a quantitative evaluation by wiping particles on the mannequins and did a particle count. The samples from mannequin 2 and 4 covered by NanoFlex were below the instrument detectable level. During our fire department visit, some of the firefighters expressed their concern over durability of the Nomex NanoFlex. They worry about if NanoFlex may be like a cotton candy that may disappear over time due to wear and tear. So we evaluated hoods that were used in the field and then washed for a period of 9 months by a variety of fire departments. So we tested a total of 9 NanoFlex hoods and found that areas were well protected by the knit fabric, all maintained blocking efficiency higher than 90%. As NanoFlex is such a unique material, special care and the handlings are required to ensure the NanoFlex integrity. Thereby, we worked with our partners to develop coated hoods to enhance manufacturing and product robustness. As the figures on the right shows, the efficiency of 2 coated hoods can all be achieved by higher than 90% of the efficiency.
Okay, so I think we need to go back one slide here. Sorry about that, folks. So I want to talk about this durability test here. Trying to come up with a real world. So washing a hood 100 times lets you know whether or not the washing machine is going to do any damage to the hood. But the reality is we don't do that in the firehouse. We don't do that in the field in our departments. We wear the hood many times before it gets contaminated, and then we wash it. But during that life cycle, to try to repeat the stresses that that hood is under we got volunteers from the Metro Fire Department near DuPont to go through a very long durability test simulating the life cycle of a typical barrier blocking, particulate blocking hood. And so we started off with 3 different samples, 3 different manufacturers. Some were quilted, some were not. And we sized them to the firefighters that were going to be putting them on. And we asked them to do a life cycle of 250 dons and doffs, interrupted every 25 by a washing. So we wound up with 10 washings and 250 don doffs. And now this don doff was not just put it on, take it off. It was simulating real-world scenarios that we would wear the hood in day to day. It starts out typically with the hood scrunched up in a ball and stuffed into the turnout coat pocket, like so many of us travel with our hood around. That's really the harshest way we would carry our hoods. We took that hood, we asked the volunteers to take that hood out and put it over their head into the staged position they normally would as they're getting ready to respond to a fire. Put their turnout coat on, button it up, then put their helmet on, respond to the fire, and at the scene, finish donning the hood, put the SCBA on first, then finish donning the hood, pulling it up and over into the area, the gap between the polycarbonate lens and the rubber gasket that we would normally have it on. Put the helmet on with the chin strap cinched up, put the collar up, throat tab closed, and then we had the firefighters move their heads up and down all around, left and right, simulating typical kind of stresses that you would experience in a fire. And then we had the firefighter remove all of that equipment in the same procedure we would normally do coming out of a fire, removing the helmet, putting the hood back to stage position, remove the SCBA, remove the coat, remove the hood, scrunch it up in a ball, and stuff it back into the pocket of the turnout coat. And that was just one cycle. We did that 250 times over and over again with those 10 launderings every 25, and then retested the filtration blocking efficiency both before the testing and then after the testing. And amazingly found that tremendous consistency and performance across all 3 manufacturers' designs, the quilted and non-quilted versions, both held up very well. So another test to evaluate how comfortable the comparable products that are on the market today. DuPont used the same test that is used to evaluate our N95 masks we wear on EMS runs. And they took that test and compared the typical hood that has Nomex NanoFlex in it, and then compared it to, you can see that in that top chart. It did pretty well, 24.5. Our typical outer shell, just the outer shell fabric of your bunker gear, has a air permeability of 14.8 there. And then the moisture membranes that we see have really no ability to effectively move air under this test whatsoever. So just comparing the different barriers that are out there, what they've come up with is then going to an NFPA test down at the bottom. You'll see the typical turnout gear has a THL. That's that total heat loss that Kevin talked about before. It's the ability of gear to allow your moisture, your perspiration, to get out from inside your gear. So 205 is the minimum, but typical turnout gear is usually around 268. And so that same test was done on a typical Nomex NanoFlex hood, and that came up with a 431. And again, as Kevin and Jan talked about before, 325 is the requirement. But these Nomex NanoFlex hoods with a Nomex interior and outside knit layer far exceeded that, giving you that superior situational awareness, the air permeability, the ability to hear. And really the evaluation of this is not on test. It's going to come down to firefighters putting these hoods in and putting them in service and getting out there and fighting fires and feeling, do you have the situational awareness that you really need? Will you feel that rapid buildup of heat? And so these are scientific repeatable tests, but I don't want anyone to think that this is the definitive answer. The answer comes from the end users, the firefighters that are out there in the field testing these hoods and giving their feedback about what they believe is the right level of protection that they have to have. So the next slide I have is going to talk about the next generation of selection, care, and maintenance of our bunker gear is going to address how do we evaluate these particular blocking hoods if we decide to outfit our firefighters with. So there's a lot of proposed ideas, some of them very intricate, some of them elaborate, many of them impossible to put in every fire station where firefighters show up for work every day. But probably the simplest one of all that has been submitted and looking for public feedback, public comment on right now, requires just using a light source. That top left picture you see there is the Nomex nanoflex that was overstressed intentionally to create a tear in the area that's in there. And you can see how easy that shows up with a simple light held behind it. It's a practical and easy to use inspection process. Every firefighter carries a flashlight. At the start of your tour, you check the flashlight. Well, you can check your barrier hood just as well by shining it through the areas that have this protective material in it and be able to identify if it's still intact. Some of those other light sources just as easily, and manufacturers might use that lighted head form that you see top middle, but certainly a flashlight is the easiest way to go about checking our hoods. So the next section we're going to get into is the systemic and better protection for modern day firefighters.
So we're reaching the end of our agenda for today, and we've gotten some questions in. We'll get to those in just a minute. But we want to talk about the barrier hood is just one part of an overall cancer prevention program in a fire department. There is no silver bullet that we're aware of right now. There's a number of parts of the industry that are taking a look at how to prevent firefighter cancer through a number of methods. Most of our conversation today has been at the bottom right of this continuum. It's been at the fireground and during overhaul. But Bob, would you talk a little bit about the studies on decontamination at the scene? So there's been some studies done about the efficacy of decontaminating turnout gear on the scene. There's been studies about using an air hose to blow off the contaminants that may be on the gear, or using just water. But the most effective means so far seems to be washing the gear or scrubbing the gear at the scene. But even then, that's just one part of that.
Thanks for picking that up for me, Kevin. Sorry about that. I lost
go ahead, Bob.
Mute button. I lost the mute button challenge, so I apologize for that, folks. So that study, the best practices that we found in Phoenix at that great symposium we were at, talked about how much more effective it is to use soap and water on a firefighter who comes out of a fire, outside of his gear is contaminated. Using an air hose just to blow them off, it was frowned upon because it just takes those toxins and makes them airborne, and that exposes all the other firefighters in the area, and certainly the person who's doing the air hose spraying. He would further contaminate others. A dry brush seemed to have very poor test results, but a soap and water and a brush definitely made a bigger difference. Really reduced the exterior amount of toxins that continued to off-gas, as a firefighter then went to remove that gear and submit it for a proper PPE cleaning. So,
I also like to chime in with Kevin and Bob. I just want to say the Dr. Gavin Horn did a study, and if we're using brush to decon the contaminated gears, it can take off about 80% of the contaminants right on the spot. So it's a good practice.
Right, that's a brush with water, right, Jan?
That's right.
Brush with water, not a dry brushing, though.
That's right, brush with water and soap. Yeah, thank you.
So there are a number of things that firefighters and fire departments can do to prevent cancer, and that includes things like smoking cessation programs, avoiding exposure to diesel exhaust if possible, especially in the fire station where it could be a chronic risk. We just have a couple slides before we get to questions. Again, I mentioned that there are a number of organizations in the fire service that are focused on firefighter cancer. The International Association of Firefighters has been focused on this issue for years. The Firefighter Cancer Support Network provides assistance to firefighters that have had a cancer diagnosis to help them get through that effort. And then the First Responder Center for Excellence on the left is a part of, as are all of the fire service organizations, part of the Fire Service Occupational Cancer Alliance. Again, it's been very heartening to see all these organizations work together completely without ego to help firefighters and to help prevent cancer going forward and to help firefighters that do currently have cancer. There are a number of manufacturers that are using DuPont Nomex Nano technology in their products now. In the right-hand column, there are currently hoods available from Firedex, PGI, and Viking. In the center column, Safety Components and Tenkate are using Nomex Nano as a component of thermal liners. There may be another presentation on that in the future. And then Globe has integrated the Nomex Nano technology in their thermal liner as a part of their entire turnout code. So we're to questions now. You can see our contact information at the bottom, and I think we're going to turn this over to Pete for questions.
Well, thank you, everyone, for joining us today. I really appreciate it. If you have any questions, please go ahead and send those in. We'll get to them here in just a moment. But just a big thanks to DuPont and Bob, Kevin, and Jan for sharing all this information with us today. Certainly a lot of information, but it's critical that this is shared truly from the top down to the bottom, and that the folks at the bottom are looking at all of these issues because it's going to impact them and their families. So thank you so much for putting this content together for us today. We'll get to some of the questions here. The first one is, what is the recommended age for hoods and gloves? I know that 10 years was the standard, but with all the carcinogens being found in these products at extremely high rates, should that change?
I'll take a shot at that and give you my opinion. Of course, traditionally in the fire service, we have, I don't know of anybody who has a hood that lasted 10 years, nor a pair of gloves that has lasted 10 years, unless that person was just doing administrative work. We have turned our hoods over in FDNY. We were issued a brand new hood every year. I know many departments that I'm visiting regularly talking about this with, they're issued 2 and 3 hoods a year. So I think that the identity of the fact that we want to maintain a high quality of protectiveness, that would be a case-by-case basis. We all know that some busy fire stations, they'll probably turn over their hoods every 3 months, but where other stations that don't see as much activity, they'll probably last a year plus. And again, same thing with gloves. It all depends on how hard they're exposed, how many times they get deconned, how many times they have to be washed. So I would say that one of the best things that 1851 does is it gives a guideline. It's not a mandatory that the gloves don't have to last for 10 years, nor the hood. It's just a maximum amount of time they could remain in the field. I hope that answers the question. It's just my opinion on this issue.
Okay, thanks, Bob. Next question is, can you please explain what the knit is?
Yes, I take that. I just wanted to give a really visual example. So socks is made of knit. Our jersey shirt is made of knit, and the reasons that the knit fabrics being used for hood is mostly because we wanted to take advantage of the materials being stretchable. So knit fabrics are normally very stretchable as compared to woven fabric. So the woven fabric example is the Turnout gear, the auto shell, and the thermal liners. They're all made of the woven material. So knits is kind of a flexible. It can be stretched, much more, longer in distances. So the firefighters can down and off in the hoods more readily, more conveniently.
Excellent, thank you. And the next question we have here is, how does a hood with Nomex NanoFlex compare to a hood without a barrier in terms of things like noise, situational awareness, movement, and the moisture management that was brought up earlier?
I'll take a shot at this too, and maybe Kevin, you want to chime in as well. So I'm retired. I don't fight fires anymore, but I do talk to a lot of firefighters that have evaluated these hoods. We've had some great, very active departments volunteer to actually, we've made some hybrid hoods that had the barrier on one side and not on the other, split down the middle. And we've sent firefighters into flashover simulators, smoke buildings, and try to just turn their head side to side. Can you still feel the rise of heat? Can you feel situational awareness? Can you hear equally? And the results that have come back are fantastic. Again, it's the end user, the firefighter in the field, that's going to be the deciding factor in this. For me personally, I think it's a great product. But then again, I'm a retired guy, and I think we're going to see more and more shared reviews. There's some good evaluations that are coming out that our fire departments have gone through real-world field trials, not just at the academy, that are going to share their experiences with everyone. And I think we're going to see some good positive results. Kevin, you want to add to that?
No, Bob, I think it's a very good answer, and the proof is in the pudding.
Okay, thank you. The next question here is, most fire departments can only afford to issue one set of bunker gear. As a result, one of the biggest barriers to firefighters conducting proper decon of their gear is the fear of being out of service for extended periods of time. Is there any research being done to decrease the drying time of washed bunker gear and hoods to get firefighters back in service quicker?
So I'll take a stab at that. This is Kevin. I think that's an excellent question and a real concern in the fire service, especially in departments that don't have as many resources as some other fire departments. And a great point. I think the industry is working now on trying to find turnout gear that is not only easier to decontaminate, but that dries faster. So I think the industry has heard your concerns, not just with PPE, not just with clothing, but with the other equipment that firefighters wear into fires. So I think it's an excellent point. I will say that there are some thermal liners, including the Nomex Nano thermal liner, that is a less thickness, will dry faster, but it's certainly a big issue that needs the attention of the service, and the industry is responding to that.
Yeah, and I think also again, NFPA, a huge task group is undertaking how clean is clean. They also evaluating different methodology of cleaning and drying, and hoping that if we find a new method which has a scientific base to show that we can use a chemical reagents or method that can wash away or decontaminate the soot in a much shorter time, much less aggressive, that can be something that it can sustain or prolong the service years of gears. So there are, again, this is a collective effort from multiple different agencies, government institute, as well as the manufacturers.
Excellent, thank you. The next question we have here is, can you again explain what TPP stands for and how that impacts firefighters?
Yes.
Sure, I'll take a stab at that. TPP is Thermal Protective Performance, and what it stands for really is the number of half seconds a firefighter will have if wearing a protective ensemble, say for, if your turnout coat is a TPP of 50, you would have 25 seconds in a flashover before you would receive a second-degree burn. So it's thermal protective, but driven down to the real-world firefighter, it's the number of half seconds before you would be expected to receive a second-degree burn through that fabric if you were trapped in a flashover. I hope that answers that question.
And I just want to say, higher the TPP, the better the performance.
Great, thank you, Jen. Okay, all right, everybody. Well, again, thank you so much to all those who attended today. We greatly appreciate it, and a huge thanks to DuPont for sponsoring today's presentation. We really appreciate you putting this information out there as the fire service is doing its best to increase firefighter safety, and all the manufacturers are working together to make sure that each group can do what they can to reduce the cancer-causing carcinogen exposures. So thank you to DuPont for sponsoring today, and a huge thanks to Bob Keys, Kevin Roach, and Jan Chun for giving us the presentation today. We appreciate you taking the time to share the information that you've learned and that you're continuing to learn with our audience. And the archive webcast will be up. You can find that at firehouse.com/webcasts if you've missed any part of the presentation. And otherwise, just stay safe, everybody, and thank you very much.
Thank you. Have a good day.